Hello YouTube, welcome back to the conservatory. And yeah, since you last saw the bike I've done a few little jobs. As you can see, the exhaust is now on and complete. I did need to do a little bit of bending of this bracket to get everything to line up, but yeah, I think it kind of suits the overall style of the bike. The other little job I've done is clutch cable and clutch lever are now fitted, and I've fitted all the radiator and the associated plumbing. So really, there's only one thing, or the next job, and I can't put it off any longer. It's time to deal with everyone's nemesis, the bit that everyone hates, the wiring. So, the devil's spaghetti as some people call it. Now, wiring seems to be an area that people really dislike, and I think people tend to overcomplicate it and think it's a lot worse than it is. So what I'm going to do before I actually do the wiring on the bike is we're going to take a little look at electrics in general, going to look at some basic hints and tips and how it all works, and there'll be a couple of little videos talking about different aspects of electrics. So let's head over to the workbench and we'll start off with the basics. Okay, so here we are back at the workbench, and we're just going to look at a basic circuit and how everything works. So the first thing you need in your circuit is a battery, and batteries come in different sizes with different codes. So in this case we've got PTX7LVS. Now this is actually the battery that's specified for an NC29. The 23 will actually use a slightly larger battery, something with a code like PTX9. And the difference is, it's this number here, and that's the amp hour capacity of the battery. Now we don't need to worry about what an amp hour is. What we do need to know is, obviously, the larger the number, the larger the battery will be, and obviously the more power it can crank out, or the bigger wattage it can crank out in one hit. So if we look at, say, the little CBR 400, this battery is perfectly adequate for that bike. But if we were to look at its big brother, the CBR 900 Fireblade, for example, then this battery is going to struggle. And the reason being is not because of the actual electrical circuit, because if you think about it, the CBR 400, like the Fireblade, twin headlights, brake lights, 2 coils, firing 4 spark plugs. The basic electrics on the bike are exactly the same. The only real difference between a Fireblade and the 400 is, of course, the size of the engine and the size of the starter motor that's required to crank it over. So in order for the battery to have sufficient power to power the starter motor, it's going to need to be slightly bigger and a higher capacity. So following that example on, if we look at something like a little CRF 250 single cylinder trials bike, that can get away with an even smaller battery than this, whereas something like my old Motor Guzzi Le Mans, which is a big old 850 V twin with a car size starter motor, it actually does run a car battery. In fact, I think it's one off the Nissan Micra that I'm using at the moment. So there's your battery. The general rule is, though, always replace your battery with the correct size battery. Batteries can come in different forms. You can get your standard lead acid battery, which is what this is. So you have a whole series of lead plates and then an acidic solution, and it is the reaction between the lead plates and the acid that creates your electricity. You can also, more often than not, you'll get gel batteries. So instead of it actually being a liquid solution in there, it's a gel. And that has the advantage that you can fit the battery in any orientation. Then we've got the newer generation of batteries, things like your lipos and things of that nature. But we're not going to worry too much about that. I'm just going to use a standard, straight off the internet, no frills battery. So, first part of the circuit from the battery, you're going to need a cable that goes from the positive terminal to a fuse box. So inside your fuse box you'll have a series of fuses, and as we'll see a bit later on, each different fuse will control a different circuit within the bike. Most common fuses these days are these blade types, but older bikes used to use cylinder fuses, little round ones, glass fuses, but this is what you'll find. They're also colour coded, so depending on the colour of the fuse will actually depend on the capacity of the fuse. And again, different circuits, depending upon their requirements, will require different size fuses. And it's the same with the wiring. The wire, depending on how much current your particular circuit is going to draw, will dictate the size of the cable required. And so something like your starter motor will have a big, thick, hefty cable. Most of your normal circuits will run cables this sort of size. And your headlights will use something a bit thicker. And then if you get to something really quite dainty that draws a very small current, like this little LED that we're going to use a bit later on, you can see you can get away with much smaller wires. As a general rule, if you're replacing a wire, replace it with a wire the same thickness as the wire that was originally there, and you won't go far wrong. So from the fuse box, you can see we could actually have multiple circuits coming off, and from there we're going to have a wire, and that will go 9 times out of 10 to a switch. Here's just an old toggle switch I've got kicking around, not the sort of thing you'll find on a bike, but it will serve for today's demonstration. From the switch there'll be another wire which will eventually lead to a multi-pin connector. The multi-pin connectors are great because obviously it means we can then plug our component in, and if we need to replace the component, you just remove the whole thing, plug in a fresh one, or as in the case of this bike, when you're dismantling and rebuilding things, you're obviously going to need to break the wiring loom into its component parts so you can actually remove it from the bike. And then finally, from the multi-connector, we're going to need something to complete another wire to complete the circuit and take it back to your negative terminal. The theory is that the electricity actually runs from your positive terminal through all your components and then returns to the battery via the cable to the negative terminal, your earth. And this is one of those things where electrical guys love to confuse everyone, and they'll say, oh yes, but it's the electrons that whiz around, they're negatively charged, and actually it goes around the other way in the circuit. But the general standard design is that everything goes from the positive through the fuse through the switch, and then onto the individual component. So now that it's all wired up, flick the switch, and hopefully you can see our little LED illuminates. And flick it again, and it's off. So the nice thing about electricity is it is literally, it's either on or it's off. There's no in between. So that is the basics of an electrical circuit. Now the nice thing is 90% of the circuits on your bike all follow the same principle. So cable to the fuse box, fuse, switch, the actual component itself could be a light, as in this case, could be something like the fuel pump, could be the coils, anything of that nature. It's all going to go into the component, and then it has to come back to the battery via an earth somehow, so that the electrons can complete a full circuit and do their business. And that really is it. It is that simple. There is nothing more complicated than that to a circuit. What you will find, however, you get slight variations in the switches. Most of them are on the positive side of the circuit, but sometimes things like your neutral switch and that can be put in the negative side of the circuit so that it can complete the circuit through the frame. The other thing, talking about your neutral switch and completing the circuit through the frame, is obviously as we have more and more circuits, you're going to need more and more wires to return everything back to the negative. So what the vehicle designers have decided to do is they use a negative earth system, and rather than have lots of negative wires, they actually return the current through the frame. So the negative terminal on your battery is actually connected to the frame, and then all these negative wires from your components will again be connected to the frame. So it cuts down your wiring by about half. So it's a good little system, and because we're only talking about 12 volts and very low current, you're not going to get a shock off it, it's not going to harm you, so that's all good. So there's the basics of your electrics, and like I said, it really is that simple. Pretty much every circuit you're going to come across on the bike will be like this. There's a few exceptions, things like your gauges, they rely on resistance, but again they still need power going through some sort of switching mechanism to the gauge itself, which then measures the voltage coming through there based on what the switch is telling it. So that's a basic circuit. So let's have a look at the different types of switches you can get. Like I said, here's a basic toggle switch. This is more of a car type. You're unlikely to find this on a bike, but what you are going to find on a motorbike is something like this, a cluster of switches. And this has two different types of switch. So there's your standard rocker switch. So in that position, the switch is open, current can't flow. And in that position, the switch is closed and the current can now flow through the switch. The other type is the start button here, which is a sprung-loaded button. So the spring holds the contacts away from each other in normal application, and then when you push it, the contacts make contact, and the current can flow momentarily until you release it. So something like the starter button, where you do literally just want to go and give it a quick buzz. Something like this, where you want the current to run permanently, or a light switch, something of that nature. You probably have a toggle switch. You can also get toggle switches that have multiple positions, like this one. So you could have, for example, something of that nature would be your high beam, low beam switch. So you have a common contact. When the switch is over this side, the current will flow through here to the low beam, flick it over across, and then the current will flow here through a relay to then fire up the high beam. And talking of relays, that brings us quite nicely on to this little thing. So I'm going to do a bit of a rewire, and I will explain how a relay works and why you need a relay. So give me a few seconds just to jiggle around with the wires, and we shall have a look at relays. So fiddle around with the wires, and I've now wired up a circuit that incorporates a relay. So what does a relay actually do? Well, a relay is a magnetic switch, and you'll use a relay where you've got something like this, like the headlight bulb, that consumes a lot of power. The problem is, so it has a high wattage requiring high current. Now the problem is on motorbikes, because we have these clusters of switches, the actual switches in the clusters by their very nature have to be quite small and only capable of taking fairly small currents. So what the relay does is it enables a large current to come to this relay, which in itself is just a magnetically operated switch, and then go to the item. So in this case we follow the blue wire from the positive, it goes into the relay, out the other side and onto our cable, onto our bulb. On the other two pins, what we actually have is we have power coming from the battery. Now obviously I've omitted the fuse box just to reduce the amount of wiring, and it comes to a switch, and you can see this is quite a small switch, not really rated very highly, similar sort of rating to what you would get in the switch gear on a bike. And then you go through the switch to the other terminal, and then again that goes back to the earth on the battery. So the idea is, and if I keep quiet, you should be able to hear the relay click. And as I press the switch, what it does is it sends power through the magnet, through the electromagnet on the relay, which actually draws two very heavy duty contacts to complete this circuit and illuminate your light bulb. So what that means is the high current is only going through these blue wires and obviously the green wire to the earth, whilst a lower current is just going through the switch. So like I said, what it means is that the switch doesn't have to be rated to the same capacity as a bulb. You can get away with quite a small, delicate switch. There's three main places where you've got relays on the CBR 400. Obviously the first one is the high beam on your bike, on your headlights, because the high beam, it's going to be round about sort of 50 watts and it needs quite a heavy duty current going through it. The low beam will only be about 35 watts, so that doesn't need such a heavy current and such heavy wires. The other area where you'll find a relay, or a solenoid as the other name for them is this thing here, and this is what controls your starter motor. So this will have a very chunky cable going to the positive on your battery, and this is actually the main positive connection, and then you'll have another equally chunky cable that goes from here down to the starter motor, and then you'll have a connection, a positive and an earth, and when you click those they will actually pull the hefty contacts in here to fire up your starter motor. And again, you would just use a button switch because you really don't want that sticking on, so it's a momentary connection. So that's the other main relay. And then the third place where you'll find a relay is on the fuel pump, and that is wired up in such a way that all the while the engine's running, there will be a signal from the coils to the relay for the fuel pump that will activate the fuel pump, but as soon as the engine stops running, then it will switch off the fuel pump. And that's kind of a safety thing, so in the event of a crash, if the engine cuts out, then the fuel pump will stop pumping fuel, because the last thing you want is fuel everywhere on a crash bike. So that's a relay. So but it is, at the end of the day, it's another kind of switch. It's just a magnetically operated switch that has heavy contacts that enables a low current to switch on a high current. So there's your relay. And that is it. The problem is, as you can see already, with just this one simple little circuit, we've got loads of wires. There would also be more wires to activate your low beam. And it all starts to build up and build up and build up, and this is the problem with electrics. There are lots and lots of wires, and even though they are generally colour coded, so you can see which wire belongs to which circuit, it's where it all gets confusing. So that's why we need a wiring diagram, and we're going to look at wiring diagrams in more detail in the next video. But before we do that, let's have a quick look at what are the common problems with electrics. Well, electrics have three real enemies. The first one is corrosion. Now, in order for electricity to flow, it does need good, clean contacts. As soon as you start getting corrosion build up, that corrosion is going to impede the passage of the little electrons, and what you'll find is that heat will build up, which is always a byproduct of resistance, and causes things to melt, causes problems. But the most important thing is it will actually stop the system functioning properly. So very often if something doesn't work, the first thing you want to do is go around all the various contacts, give them a good clean with a good contact cleaner, or if you haven't got contact cleaner, brake cleaner will do, or if nothing else, a bit of WD-40 and a wire brush so you can clean all the corrosion. That will solve most of your problems. Unfortunately, there is no way of preventing moisture getting into the circuit. And if we take this switch here, a lot of problems are caused with bikes not starting purely because moisture has got into this actual switch and actually caused corrosion on the contacts, which prevents your kill switch from actually closing the circuit and allowing electricity to flow. And nothing will work without the kill switch. The nice thing is with these switches, if I can overcome the little bodge that we've got on here to replace the missing screw, is you can actually dismantle these switches. You can get in there, and again you can almost see there's a little contact here, and you can get in there with your contact cleaner, give it a good clean. If you really have to, you can actually dismantle these switches to get into the components better. But if you are going to dismantle them, be very, very careful, because what you'll find is there's often little spring-loaded components, very small fiddly screws, all the sort of stuff that likes pinging off into the distance and disappearing off on your workshop floor, never to be found again. So if you are going to dismantle the switches to clean them, be very, very careful. Do it on a workbench with a bit of paper down to catch everything. So there's corrosion. As I said, there's not a lot you can do to prevent corrosion. It's a 30-year-old bike. Eventually corrosion is going to get into your circuits, into your wires and your connectors. So yeah, and what you will find is with the corrosion, as it comes in, instead of your wires being a nice bright coppery colour, they'll start to go this dark brown colour. And when wires go dark brown, really, you just need to take them out and replace them. So there's corrosion. Again, giving everything a regular clean and a coating of, a bit of Vaseline around some of the contacts can help. A little spray of WD-40 will help keep the moisture out. So there's the first issue, moisture. We hate it, as do electrics. The second issue is vibration and movement. Now, over time, these little contacts are going to jiggle around, and again, causes the contacts to open up. It causes the actual crimps between the connector and the wire to work loose. So again, you're reducing the effectiveness of the contact or the connection between the wire and the connector itself, or even the component. So vibration is a big problem, as is chafing. It's very easy to chafe through the outer plastic insulation, and that's what causes shorts. So you'll often find, the CB1 is a classic. The main wiring loom passes around the headstock, and then there is an aluminium cover that almost clamps it in place, and over time that cover will chafe against the wiring and eventually expose the wires in the wiring, causing a short. But that's where your fuses come in. So as soon as fuses start blowing, you know you've got a short somewhere in the circuit. So the other thing is, with vibration, is it really helps if you use the right connectors. So I'm using these connectors here for this circuit. They're the sort of thing you can get from Screwfix, Halfords, all your regular high street retailers, but they really aren't designed for use on a motorbike. And the reason they're not designed for use on a motorbike is the actual connection is not very good. These cables literally rely on just being squashed against the wire. So you start off with something like that, your wire goes in and it literally just squeezes. Obviously over time the wire's going to vibrate, that's going to loosen up, and it comes apart. So what you actually want is to use the proper connectors, and this is a proper motorbike connector. And you can see, rather than just being crushed into the wire, it's got the two tangs, and they actually grip in like that, which gives a much more grip in like that, which gives a much more positive connection. Now, back in the good old days, before online shopping, we might have had an excuse for using these sort of things, because there weren't very many places that could stock these. Even your local motorbike dealers were very reluctant to sell you these. So we often had no choice. But now there are plenty of electrical specialists, things like Vehicle Wiring Products, CoJCat, all these people who sell the connectors online. In fact, I recently bought this bag here, 100 connectors, for about £2.50. And they come in two types. You have the male and the female. And obviously designated male and female for obvious reasons. The male goes inside the female. So try not to use these connectors. If you can, use the correct connectors. They can be found online. If you're looking for these connectors, they will be listed as a 2.8mm connector. Also, when you get the connectors, or when you're buying the connectors, make sure you buy the correct type. And if I have a look at this little bag here, what you should see, no, they're the wrong sort. What you will see
is that the connectors should have a little tang on the back, and that enables you to put it into your multi-pin connectors and hold them in place. But we'll talk a bit about that in a while. So try not to use these connectors. If you really are going to use these connectors, make sure you buy a correct tool for it. I'm sure we've all come across these horrible little things that you get in pound shops and cheap toolkits. There's only one thing to do with these: throw them in the bin. They're a complete waste of time. What you actually want is one of these, a proper ratchet connector, so that you put it in, and you can see it's colour coded, so you do get these connectors in different colours to suit different thicknesses of wire, and then that will ratchet down and make a pretty good crimp, but it really isn't the best. So there's connectors and corrosion talked about, and then finally, following on from this subject, your biggest problem: previous owners and their bodges. Again, as I said at the beginning, it does seem to be that wiring scares people, so rather than take the time to do it properly, or because they're in a hurry and they just want to use what's available, they'll use the wrong type of connector. So one of the biggest problems is with these connectors, they generally come as uninsulated connectors like this. You can see the end of the connector here is exposed, and I recently had a CB1 I was working on, and it kept blowing a fuse and I couldn't figure out why. Eventually I traced the circuit down, and what happened is someone had used these connectors on the brake light switch underneath the front brake lever, and what was happening is these two connectors were touching and completing the circuit, which was causing the fuse to blow. So if you must use these type of connectors, do something like this, which is what I ended up doing on the little CB1, and covering them with some shrink wrap. The other sort of thing we find is, this is off a bike I recently dismantled, is people joining wires together. Now if you're really unlucky, they'll just take the two wires, twist them together, and put a load of insulating tape over it and hope that will hold. It won't. If you're a bit luckier, they'll use something like this. Again, Halford crimp connector. So you put them in, you crimp them, but over time they will actually, you can actually see the wires are moving on this one, and lo and behold, you could actually pull that out quite easily. There really is no need to do that on one of these connectors, because, like I said, you can buy bags of the correct connectors, and you can actually remove the old connector from the block, replace the wire, or replace the connector, with the correct sort. Now what I'm doing here is using this little tool, which is just a shaped bit of metal. Whoops. And what that does is it depresses the tang on the end. You can pull it out, and now you can make up a new wire with the correct connector, and that will just slot back in. So in order to remove the connectors from the block, if you have a look, what you will find is there will be your block, and it will have all your connectors in, and each connector will sit in a T-shaped hole like that. So if you insert your little tool in the top of the T-shaped hole like that, that will push down the connector, and as you can see, you just pull it out, take a new piece of wire, new connector, replace it and crimp it. I don't know why you see so many people on YouTube using these horrible things. However, in order to fit these connectors, you do need the correct tool to form it. So again, it's another tool you've got to buy, but what this tool will do is it will actually create the correct fold in connector. You'll see all sorts of other bodges. So often you see it where there's a problem, and rather than actually sort out the problem and sort out the wire that's a problem, they'll just run another piece of wiring through. So yeah, so your third most common and biggest problem is the bodges that other previous owners have done to your bikes. One final thing I'm going to talk about, the dreaded Scotch lock. These have absolutely no place on anything. They are a nasty, horrible invention that should never be used. So again, throw them away. If you do need to join two wires together, well, you're going to have to learn how to solder. Now, the one thing I'm not going to talk about is soldering. You will probably see me do a bit of soldering later on the wiring loom, but there are plenty of people doing videos who can solder far better than I can, who will show you the correct way of doing it. So that's my basic intro to electrics. So we've talked about the basics of a circuit, some different kinds of switches you're going to find, the different requirements in the thickness of the wires, and things to avoid and common problems. So hope that all made sense. Sorry, Matt. And in the next video we're going to look at wiring diagrams, which are, again, not as scary as everyone thinks they are.